Hello, everyone, and welcome. I am Zoe Bowen-Smith. I'm a communications specialist at the ICCT. Thank you so much for attending today's webinar, How Can U.S. State SAF Policies Pave the Way for Decarbonization? This webinar is being recorded, as you heard, and we will send out the recording to all participants sometimes next week. Everyone has their microphones on mute. If you have any questions, you can write them in the questions block at the bottom of your screen. It should say Q&A. After the presentation that will last about 30 minutes, we will have an additional 20 minutes to answer questions from you all in the audience. Leading the presentation on U.S. state SAF policy is ICCT researcher Andy Navarrete. For the Q&A session following his presentation, he will be joined by two colleagues, senior researcher Jane O'Malley and ICCT Programs Director for Fuels and Aviation, Nick Pavlento. Let's kick it off to Andy to get us started.
All right, thanks, Zoe. I'm going to go ahead and share my slides here. Cool, so I'm just going to go ahead and jump right in since we got a lot to cover. Starting with a little overview of the presentation. So I'll start with some background just to make sure we're all on the same page on these topics. Then I'll get right into the different U.S. state SAF policy types, particularly the tax credits and SAF and clean fuels programs. Then we're going to shift gears a little bit and look at what we think here at the ICCT makes a good SAF policy, focusing on the key issues of sustainability, equity, and long-term decarbonization. We'll run through some of the highlights and lowlights on the state policy scorecard we put together. And as Zoe mentioned, we'll have a Q&A at the end, so be sure to put your questions in the chat as they come up. So background, sustainable aviation fuels are essential to decarbonize aviation. What you're looking at here is just a roadmap put together by the FAA of aviation emissions going out to 2050. The red dotted line at the top is kind of a worst case scenario where 2019 technologies are frozen and we get this increase in emissions coming from further aviation demand over time. And you can see though that to get down to net zero, 70% of those reductions are going to have to come from SAF in this particular roadmap. And looking at other assessments are, 50 to 70% is pretty standard there. And this is a big challenge. So here I've put the fuel volumes from the Biden administration's SAF Ground Challenge targets and also where we were at in 2023 at only 26 million gallons of SAF used in the US. And what's pretty clear is that to get anywhere close to these targets, we're going to have pretty much exponential growth of SAF production and utilization in the country. So that's why, some of these policies are appealing, is to try to, really get this thing moving. Something that is essential to understand these different SAF policies is the concept of carbon intensity, which is basically an accounting of the life cycle emissions that go into making a fuel and then using it in the aircraft. So this is an example for used cooking oil-based fuel, where there's a certain amount of emissions associated with collecting the feedstock, transporting it, then converting it into a fuel, and then transporting that, and finally, when it's actually used on the aircraft, we're not counting the emissions there because the CO2 was captured from the atmosphere when the plants grew that made the cooking oil. So those are not counted. And to see how much greenhouse gas reductions we get, we compare this to the equivalent accounting that you would do for fossil jet fuel. And so the savings are the difference between what you would have for fossil jet versus these other alternative fuels. And what makes this whole thing very complicated for policymakers and in general is that there's a lot of different types of SAF and that they all have very different characteristics, both in terms of this carbon intensity I was just telling you about, but also how um, technologically mature they are, um, and the potential supply that you could how much of this you could actually reasonably expect to produce, and also the cost of production. So at the top here, we have represented the 2023 total fossil jet fuel consumption at 25 billion gallons. And then for these different fuel pathways, so this is different types of SAF, different feedstocks, and conversion pathways, we have estimates of how much we could supply domestically for each of these pathways. Um, with the more technologically mature or already commercially deployed pathways up at the top. So then in the middle, we have the carbon intensity of these different pathways. So the green ones are giving you greater savings relative to fossil jet fuel. Then the estimated production cost, you can see there's a range here. So the cheapest to produce is this waste oil, HEFA fuels, a little over $4 per gallon, whereas power to liquids, more expensive, not as not yet commercialized, so the furthest away in terms of technology development. So with that kind of background in mind, there's all these different types of SAF. CI is important. Let's get into the policies. So different states have taken different approaches to this. There's kind of three major ones. One is to do SAF tax credits. Get into that in a second. The other is some states have clean fuels programs, like in California, there's the low carbon fuel standard. And so you can allow SAF to opt into that program and generate some support there. And then there's also been some states that have done support for um, SAF production facilities specifically. So some states have had bonds to support construction, or there's also like tax relief for the materials used in construction, things like that. Um, Turning to the tax credits. So the idea with the tax credits is, this tax credit offsets the cost premium of using these fuels, which are more expensive than fossil jet fuel. And what you can see is in the different states, the structure of these credits, both the value and how it relates to the carbon intensity of the fuel is different. So, for example, in Hawaii, any fuels that are alternative fuels, lower carbon than fossil fuel, get 33 cents per gallon, regardless of the carbon intensity. Whereas in Illinois and Minnesota, you need to hit a 50% reduction threshold. And then as long as you hit that threshold, you get $1.50. Whereas in Nebraska and Washington, um, there's that same 50% threshold, but then there's also a bonus for further savings. So if you had 100% greenhouse gas reductions, that'd be a CI score of 0, you would get the maximum tax credit value. The other approach here for the states that have clean fuel policies is to allow SAF to opt into these programs. And so the way these programs work is there's a benchmark carbon intensity score, which declines over time, so the program becomes more stringent. And fuels with carbon intensities that are above the benchmark generate deficits. So the suppliers of those fuels have these deficits, and then suppliers of fuels that have a carbon intensity below the benchmark generate credits, and so then the people, the suppliers who have deficits have to purchase these credits, and that way it supports the lower carbon fuels. And so then in this context, the value of the credits for a SAF would depend on three factors. It would be the carbon intensity of the SAF, so that would determine how far away it is from the standard. The current benchmark, so what year is it? So that determines how many credits you get. And then finally, the market value of the credits, which is determined by the supply and demand of credits and deficits in the program. Um, and for these different states, what they've done is there's no obligation on fossil jet fuel providers to fossil jet fuel doesn't generate deficits. That's why it's called an opt-in, is that SAF is able to opt in to getting credits even though aviation isn't covered more generally. And what we can do with these different tax credits and making estimates of the credit values, et cetera, is to look at the support of the different states for different types of fuels based on their carbon intensities and other rules that they have. I'm not going to run through this in great detail, but I urge you to check out our paper where you can look at this more carefully because it would take a while to go through. But you can see that generally, the more advanced fuels are getting more support from the federal credits, which are these brown boxes, and also more support from some of the states that have this mechanism to provide more support based on lower carbon intensity fuels. So shifting gears a little bit into the key policy issues. So one thing we wanted to do with this work is think about kind of holistically what makes a good SAF policy. And so we kind of thought about it in these three buckets. So number one is sustainability. How effective is the policy at driving an overall reduction in greenhouse gases in the atmosphere while avoiding negative environmental impacts? So that's kind of the whole point of using these fuels, right? The next one is equity. So we want to see, are these policies, an effective use of kind of the state's capacity and resources? And then finally, we want to see if policies are useful for driving long-term decarbonization. As we saw in the intro, we really need exponential growth of SAF production to meet these targets. And so if the policies just kind of supporting the status quo, that's not very useful. It needs to be designed to actually kind of accelerate this transition to be most effective. So the major sustainability issue with these policies right now is that the feedstocks for the commercially available HEFA fuel pathway are limited in supply, and they're also the same ones that are used to make biomass-based diesel. Um, so right now in the US, biomass-based diesel, we're producing 4.3 billion gallons of it in 2023, and this production has already exceeded the domestic supply of these feedstocks. So we're importing feedstocks to make bio-based diesel in the US. We've essentially exceeded our capacity domestically. And just to review these feedstocks, so we've got the vegetable oils, animal fats, used cooking oil here. And so these feedstocks are limited, and one of the key issues with SAF is that for a given feedstock, if you're using it to make renewable diesel or biodiesel and using that to replace fossil diesel, you're actually getting better greenhouse gas savings than you would if you were making HEFA SAF and then substituting that for fossil jet fuel. So, for example, for tallow, renewable diesel gives you 68% greenhouse gas reductions compared to only 64% for SAF. And you might think, well, we should still do SAF because we're going to decarbonize the road sector with electrification, which I think is true in the long run. But the issue here is that diesel fuel demand is going to exceed the supply potential of either of these pathways well into the future. So looking at some ICCT estimates of future demand for both diesel and jet fuel. In the ICCT ambitious scenario, 2040 US diesel consumption will still be almost 30 billion gallons. Um, so in as long as that diesel demand is out there, that there's still these diesel vehicles, you're getting more greenhouse gas savings from using these feedstocks to produce uh, diesel fuels rather than jet fuel. And so what we conclude from this is that if SAF policies are incentivizing this diversion from bio-based diesel to SAF, the net result is actually an increase in greenhouse gas emissions. So not what we're trying to accomplish. Um, there are some other challenges with, you might think, well, let's just try to find more of these feedstocks where we can. And this becomes really tricky because there's essentially a globally connected market for these bio-oil feedstocks. So what you do in the US is going to have ripple effects essentially throughout the broader global markets. And you can see that illustrated where we look at the price movements of different oils, so palm oil, used cooking oil, soybean oil, et cetera, over time. And really illustrates that this is a global market. And so, for example, if we divert US vegetable oil from export and instead use that to make fuels, what's most likely going to happen is that the countries who are no longer receiving those imports are now going to import vegetable oils from places like Indonesia or Brazil, where there's a lot of deforestation going on, land use conversion to agriculture. Um, Use cooking oil. We can try to import more of that too. There's a big risk of fraud there. It's hard to verify these supply chains overseas. Um, and also, another issue is that other countries have biofuel policies too. So if we're paying a premium to use the feedstocks that they were already going to convert into biofuels in their countries, again, that's not um, really leading to overall reductions in greenhouse gas emissions. And then finally, there's this issue of shuffling of HEFA-SAF between states. So you can imagine if one state has a tax credit that's more valuable than some other state, fuel suppliers are going to say, okay, let's just move the fuel to that state, get these tax credits. And you can already see this has happened in California in the case of biomass-based diesel, where since 2016, the amount of biomass-based diesel used in California has gone up, but it's actually gone down in the entire rest of the country. So that diversion of fuel from one state to another, again, that's not giving additional greenhouse gas reductions. So, what are some of the policy solutions to dealing with this? I think that the most straightforward one, and some policies, particularly in Europe, have started to take this approach, is to have a cap on the amount of fuel supported from these pathways that are fundamentally supply limited. So kind of in proportion to the, state's share of use of that type of fuel, for example. Um, in terms of avoiding these indirect emissions from, vegetable oil supply chains and deforestation, it's important to incorporate that into your life cycle analysis, into your CI scores, using these induced land use change penalties. Should have written that out. And then probably less effective, but still useful, is to address some of these non-greenhouse gas environmental impacts. Policies like CORSIA include sustainability standards that fuels have to meet. And at least that allows regulators to kind of make an assessment when, like, hey, what we're doing with this policy isn't really on a sustainable track. There's room for intervention there. Okay, so turning to the next issue, equity. So who should pay for aviation decarbonization? Using SAF is expensive. If there's less expensive ways of reducing greenhouse gases, how do we justify these policies? I think there's two ways to sort of justify it. One is if you can design the policy so the polluter pays. If fossil jet use is penalized and the funding comes from that source, that can make sense. Another more feasible option for states is to look at co-benefits. So, for example, if you're having supporting in-state SAF production, that's also providing jobs, economic development, and also looking towards this long-term technological development. Obviously these things are expensive to do today, but we also need to have some technological learning there. And so a co-benefit of these policies, if we're actually supporting pathways that still have some learning to do, I think that's a good justification for why SAF support is useful. And that's a good segue into this last question of long-term decarbonization. So, um, we really need to grow the supply of SAF. How can states aid the deployment of these less mature technologies that we have down at the bottom that are offering the best greenhouse gas reductions, but are currently expensive and not fully commercially developed? Um, and so there are two major things here. One is that you really need certainty and longevity in your policies. So what we're looking at down here is kind of a timeline of a typical SAF project. And so planning could take, 3 years, another 3 years for construction, and then 25 to 30 years of production. And if we look at some of these policies, for example, the Minnesota tax credit, that will have basically expired by the time a facility that's just getting into planning today, um, gets finally enters production. And so if you're an investor or a project developer thinking about getting into SAF, building a new SAF plant, the Minnesota tax credit is not going to be a motivating factor for you. Whereas a policy like the low carbon fuel standard, which we expect to be around well into the future, uh, is going to be more motivating where you think, okay, this is going to contribute to my bottom line once this facility actually enters production. Um, Another thing we think is helpful is to apply a direct relationship between the greenhouse gas reductions and the uh, value of the support you're getting under the policy. So the 45Z tax credits, which were part of the Inflation Reduction Act, provide a good illustration of how this might work, where instead of having like this threshold where then you get $1 per gallon, for example, in Washington, in 45Z, it's just a direct relationship between how much greenhouse gas savings does your fuel give and what's the value of the tax credit. And so this is going to most incentivize these more advanced low CI pathways, um, with less support for the pathways that are not doing as much. Okay, then lastly, we'll just run through some of the things in the policy scorecard. So what we did for the paper was we ranked or we scored each of the different state policies on each of these different categories that I just ran through briefly. And then based on that, we gave them an overall letter grade. Um, and so what I'll do now is just run through some of the highlights and lowlights from the different policies. And again, encourage you to check out the paper, which goes into some more detail. Um, so in terms of long-term decarbonization, definitely a highlight is Washington's commitment to long-term support for SAF and linking the support values to greenhouse gas savings. So Washington has both a tax credit and has SAF able to generate credits in its clean fuel standards. So there's quite a lot of support available there. And both of those are structured so that the more greenhouse gas reductions you get, the more valuable your credits are. And neither of these policies are set to expire. So we think that the policy longevity there is going to be an effective signal to producers that, hey, we can rely on these policies moving forward, and let's actually, get some of these facilities constructed. Second highlight in terms of sustainability safeguards. So Illinois placed a cap on the volume of soybean-based SAF eligible for tax credits. And, um, we applaud this because it's really the only recognition in these policies that these HEFA feedstocks are limited. I think there's overwhelming evidence that these feedstocks are limited. And so if all these states are just competing to drive more production from a limited feedstock, the consequence will just be driving up the price, not really reducing greenhouse gas emissions, not very useful. So this cap is a step in the right direction. And then on the equity front, we like Nebraska's tax credit is going to fuel producers rather than suppliers. And so that's supporting in-state production, which, kind of more useful for the general population that might not be flying quite as much. Fortunately, Nebraska also goes on the lowlights. So they had a great policy, but it's only 5 years long. And, um, you know, based on our analysis, that's probably not really enough to motivate, to strongly motivate a producer to, move to Nebraska specifically and get up and running in the state, given the long life of these facilities. Um, Washington, uh, they have these great programs, but they have no safeguards against over-supportive HEFA fuels. And so the concern here is that they're going to be kind of the biggest target for shuffling, where they have the most generous credits for UCO, HEFA SAF, for example. So there's going to be a lot of incentive for suppliers to just shift those fuels to Washington. To get those credits, even if they would have just been used in another state otherwise. And finally, you know, as a country, both at the state level and the federal level, we're really trying to make this whole thing work with a carrot-only approach. Just, throw these subsidies out there and kind of hope that it'll all work out. We put this category here because originally California was going to have an obligation on at least the fossil jet fuel used on flights within the state, but they removed that. So now there's basically no restrictions or funding coming from uh, the use of fossil jet fuel, and that's maybe not the best way forward. Um, so, conclusions. I think the number one conclusion is aviation decarbonization is a marathon, not a sprint. We have a long way to go here, and policies need to take that into account in how they're designed. If they're just sort of these temporary short-term measures, that's not really going to put us on the pathway we need to get on. The second one is that understanding the impact of these fuel policies really requires analysis of these cross-sectoral interactions. So, between the road sector with diesel fuel and aviation, for example, and global commodity markets with the impacts that, using vegetable oils, for example, is going to have across the globe. And the result of these interactions is that you can use SAF, but that doesn't necessarily guarantee a net reduction in overall greenhouse gas emissions, which is really the goal here. So this is pretty important. And finally, it's clear that to get to where we're trying to go, um, advanced, not yet commercialized SAF pathways are needed. So I think where states have the biggest opportunity to make a difference is having policies that enable the commercialization of these technologies, even if it's at a limited scale, um, we're still learning by doing. And, once these things can be demonstrated, that makes it easier for future investments, that kind of thing. So I think that's really where the focus ought to be. So with that, thank you all for listening, and I think we'll turn things over to questions.
Wonderful. Thank you, Andy. Great job. And what an informative presentation. Yes, as Andy said, we're now going to start turning to your questions. So if you have any questions, we've already had some come in. Please put them in the Q&A box at the bottom of your screen, and we'll try to get to as many as we can before we run out of time. And now Jane and Nick are joining us. I'll let y'all take it away.
Sure. So thank you all for listening. Let's get started with some questions. We've got a few questions prepared already, and I also see there's a few trickling in through the chat. Please, I encourage you to add some. But let's start with a question from Alexandra. So, Andy, do the tax credits go to the fuel producer only, and how would it change if credits go to airlines?
Yeah, that's a good question. So it actually depends on the different states. And so in Illinois, for example, the tax credits do go to the airline, whereas in Nebraska, as I mentioned, it goes to the fuel producers. I think in some other states, it goes to the fuel suppliers. And so um, I think the primary difference there, if it goes to the producer, that means it would have to be produced in state because the tax credits are for the state, they're against state tax liability essentially. Whereas if it's to the supplier or the airline, that could be either one of those could be for fuels that are brought into the state and just used at airports in the state.
So, with the possibility of setbacks on climate policies generally, perhaps even the implementation of the IRA and SAF tax credit at the US federal level, what can states do to support SAF deployment? Are there restrictions on what they can do due to federal preemption? What's the template for success at the state level?
Yeah, I can start on that, and Jane, please jump in too. I would say that the template for success, the real advantage that the states have is more political stability often. And so if they're able to put in place a durable policy that really gets some of these more advanced pathways like off the ground, up and running, um, that is going to be the most useful. And so I think to do that, we kind of went through, having a tax credit, for example, that once you enter production, you're guaranteed 15 years of that credit, for example, would be very useful. And I think um, it might make sense to have more valuable credits on a per gallon basis, but sort of scale the support to what makes sense in the context of the state. So, it might be that the state thinks it can support one or two moderate sized facilities and sort of design the tax credit around trying to do that, but really get those projects built up and running. And that way, you know, we'll be working on these technologies that then hopefully once we get a more favorable national policy, they'll be kind of ready to go, proved out, ready for investment. But Jane, I'd like to hear
Sure,
any
I
thoughts you
can
have.
compliment. Thanks, Andy. So yeah, certainly the pause or reversal in federal action might be a setback for the ability for the U.S. to take on greater ambition for setting a mandate for SAF or providing certainty at the federal level for creating a market for SAF in the U.S. But states certainly still have opportunities to leverage their existing resources. So as Andy noted in his presentation, there's a lot of opportunities for providing grants, providing different financing schemes such as contracts for difference and other strike price schemes that you can help build a market for SAF and scale up advanced pathways that we know we really need. So I think states can do a lot of work to help scale up the important advanced pathways and work with what they have and utilize their existing resources to build markets where later, hopefully, the federal action gets on board.
Yeah, and I'll just add one thing too, from some other work we've done. a real challenge that some producers faced is funding the feed study, which is basically the engineering of their facilities. And I could see how states kind of providing support for a feed study for a facility taking place in their state might be a useful way for getting these projects moving at a stage when it's hard to attract investors, just to do an engineering study, but it still requires quite a bit of money.
Here's a question. I think this is better suited for Jane, from Lucas. Does your methodology for feedstock supply account for fleet electrification in the US as a factor?
Good question. So when we do our assessments of feedstock supply, we look at different data sets that are on biomass availability, so stuffs like yields and crop production. And then if you're thinking about feedstocks that are waste oil based or animal fats based, we rely on federal data that's been published on how much is out there, how much is traded, what's its relative price. So we are not so much looking at the federal electrification targets. There are some considerations if, as we electrify, there could be possibly less ethanol used in the road sector. But here we're really considering that certain feedstocks have existing uses and competition outside the road sector. So we're not necessarily building in the road sector targets into our methodology, but it's certainly something to consider in a broader qualitative standpoint.
And just to add to that, just specifically in terms of what's being used in the road sector, for the corn availability on the graphic we saw a few slides back, that's essentially the RFS obligation, but just put through the alcohol to jet process and turned into gallons of jet fuel, taking into account the conversion loss and the other co-products. And same for soy and waste oils. And I believe for the soy, there's also a scenario with increased crushing of domestic soybean supply and exporting just the meal rather than exporting whole soybeans. Okay, we have another question. I think this one is well suited for Andy. Do you see any scope for coalitions of states acting together versus individually?
That's something I hadn't thought of. So maybe, I guess, is the answer. I don't know. Nick or Jane, do you have any immediate thoughts? That one actually really caught me off guard.
I will share. So states have in some ways acted together, not quite, by building off work that's been done in other states. So California, as we know, has been the initial leader in developing policies for SAF via its low carbon fuel standard. And other states have worked with that methodology to develop their own standards. So we really have like a good base or foundation of methodologies and information that's out there that states can use and build off of and tailor to their own needs of their given state. So that's one example. I think it's a cool idea. Like there's examples in other market schemes like cap and trade, like RGGI, there's a coalition of states that have worked together to do their own cap and trade program. The West Coast states also have some interlinkages between cap and trade. So I think there could be opportunities like leveraging what we've learned from those sorts of schemes used in different policy applications.
And yeah, I'll just add now that I had a moment to think about it. Thanks, Jane. I think it would be useful too, actually, this issue of competition between states that I mentioned. If states are aligned in what their policy is, then that kind of removes this issue where, oh, the credit values are slightly higher here than over there. And so producers are kind of like trying to game the system to take advantage of that.
Okay, I see not one, but two really good questions from Fayez in the chat. I'll try and answer them both, but Andy and Jane, feel free to add on anything. So on the status of 45Z, has it been paused? How much is missing from the guidance? How does it affect project planning? So the 45Z is in an interesting situation because unlike 45V, the hydrogen tax credit, it's just a proposal. It's not final guidance. It's not in the Federal Register. So we're going into the next year with a lot of uncertainty on the timeline for how it will be finalized. if it will be finalized, and what will the final version contain. And so that uncertainty is definitely going to have a ripple effect on project planning, because you're not certain if your project is going to qualify and how much credit value it's going to generate. And so additionally, it seems as though support for 45Z is tepid at best within the administration. You have some advocates for it, certainly, but you have a lot of criticism and interest in overturning key portions of the Inflation Reduction Act. So I would say 45Z is a great source of uncertainty for now. I've also heard that due to the delay for how long it's taken to put out a proposal for 45Z, it's also attracted a lot of criticism from within the biofuel industry. There's a lot of appetite for, setting aside the complexity of 45Z and just going for a clean extension of the 40A biodiesel tax credit, no CI, just a easy to understand dollar per gallon of biomass-based diesel. Now, on your other question here, what needs to happen for US-based ethanol to have a low CI score to qualify for credits? I think there's an interesting question here and a lot going on, because it is one of the highest GHG pathways in this analysis. But by that same token, it also has a lot of different levers you can use to reduce the emissions to qualify. So there's things you can do directly within the LCA, within the product supply chain, that can have a big impact. So for example, putting in CCS, there's one project right now that does that, Red Trail Energy, and they can generate a 30 gram or so reduction. I believe they're already approved under the Oregon Clean Fuel Standard. You can use RNG, renewable electricity, green hydrogen on site and generate measurable greenhouse gas reductions within the supply chain. But there's also other ways to get a low CI score to qualify as well. You can have a low indirect land use change emission factor. This is much easier because you don't really have to do anything for your supply chain or your project. You just hope that the regulators survey the literature and choose a low one. And so that's likely what happened during the final stages of the 45Z process. And then there's also the option for soil carbon credits. This is something that's not in 45Z yet, but it is being piloted in USDA's proposed technical guidance for biofuel production. And the idea here is you can have a soil carbon offset bundled with your fuel pathway and generate a lower CI based on those credits. Now, this is a source of a lot of debate and complexity because it hasn't really been done in very many fuel policies before due to the difficulty of measuring and verifying those changes in soil carbon. It's quite challenging to measure on-farm changes in soil carbon levels. Okay, we have a question. Put this to Andy and Jane. What are your views on book and claim? Can that help promote SAF in states?
Yeah, I'll jump in here. I would say that I think book and claim can be okay if it's like at the level of the final fuel use. Um, so, if companies want to support SAF and it's not currently possible to deliver it to the airport that they operate out of, I think book and claim can be useful in cases like that. What becomes problematic is the use of book and claim within like the life cycle analysis, um, where then you're sort of it opens the door to offsets essentially, where you're claiming that the fuel that you have is lower carbon intensity based on some things that other people are doing somewhere else. That's not directly tied to the fuel that you're using. So I would make that distinction where I think for the final end user, it can be useful, especially in these early days where It's not widespread throughout the country, but you have to be really careful when it tries to make entryway into the life cycle analysis portion of things. I don't know if you have anything to add, Jane.
No, I think you summarized it well. Yeah, there's some complications when it's involved with emissions reporting and possibilities for double counting when you're dealing with book and claim. But for, let's say, states that have a lack of domestic or regional SAF resources, it could be a way to meet targets, but just keeping in mind like the possibility of shuffling feedstocks throughout different states and what sort of goal you're trying to achieve.
Andy, here's a question for you. What are the best ways to encourage innovation in feedstocks?
Innovation in feedstocks. I guess I would say it's tricky because you need to, yeah, make sure that the feedstock, make sure that your process is something that's not, that's going to be viable without an extreme level of policy support, is what I would say. Um, there's cases where it seems like pathways might be designed in a way that maximizes the value of these different credits, but if you took away any kind of leg of that stool, then the whole thing kind of comes tumbling down in terms of economic viability. So I think in terms of innovations regarding feedstocks, um, what we've learned in general is that any new feedstock, you really need to design your process around the very specific characteristics of that feedstock in terms of your fuel production pathway. And so I think what I would say is, start at a modest scale, see if the process works, the economics work, and once you've kind of figured out that this truly makes sense and has that opportunity to scale, then move forward from there. But I would caution against, just kind of going all in at an excessive scale based on the idea that you're going to stack the RFS and these different tax credits and avoided carbon and all these things, because, you're kind of putting together a house of cards, and I don't think that we're going to scale the whole industry that way.
I have another 45Z question. So for the purposes of calculating a credit, if a flight goes to Europe or to Asia, how is the credit calculated? Would a state use CORSIA GREET, California GREET, or 45Z, depending on how producers want to get credit for their SAF?
Yeah, so the different states have different ways of calculating the CI scores. A lot of them make reference to the federal rules, although generally it's 40B, which is the current SAF tax credit. And so, for example, in Illinois, you could use either um, the 40B SAF GREET, or you could use CORSIA. So they would have an option there. Whereas in Washington, they're required to use the Washington GREET, which is associated with the Washington Clean Fuel Standard. The destination of the flight doesn't really matter. It's more the location that the fuel is uplifted and the tax credits that they're applying for.
So here's another question. This one is for you, Jane. Why are fats, oils, and greases so appealing as a SAF feedstock? Can you speculate on the impact that state-level SAF policy might have on the market for these feedstocks?
Yeah, definitely. So fats, oils, and greases, this is typically feedstocks like used cooking oil. Animal fats are very attractive because they can be processed in an already commercialized technology pathway. This is the HEFA technology pathway, so they can be processed through a biorefinery and produced in the same product slate as renewable diesel. So it's attractive to producers because there's not as much CapEx investment required or technological barriers to scaling up these resources. But the big problem when it comes to these feedstocks and this technology pathway is that they're very supply constrained and resource limited. So we've done a lot of assessment at ICCT to figure out how much of these feedstocks are actually out there. And unfortunately, there's not a ton. So we're only going to chip away a little bit at our necessary SAF demand requirements with these feedstocks, and we really need to take time to actually scale up ones that have more longevity or longer term supply potential, in addition to having a very good greenhouse gas performance. I forget the second half of the question with.
Sure. Would you be able to speculate on the impact that these, this patchwork of state level policies could have on demand for these kinds of feedstock?
Yeah, so if every state adopts their own sort of SAF tax credit while relying on the HEFA resources, we're going to quickly use them all up. They'll be dry pretty soon. So like right now, the majority of the waste oils are being directed to California, where the market is the most mature, and there's additional incentives for these feedstocks. But unfortunately, because there isn't enough of them to go around, they could open the door for the possibility of fraud. We've done some research on this, and there's been some pretty compelling evidence of waste oil fraud going on when we're importing the feedstock from different markets, particularly in Asia, because it's quite easy to label these waste oil feedstocks as being waste oils when in fact they're coming from virgin vegetable oils, which have a much higher upstream land use emissions impact. So by not being careful in terms of designing policies and opening the door to too much feedstock consumption, we could risk the possibility of fraud and shuffling among the many different states.
Yeah, good point. And I just see a comment in the chat about a possible UCO or used cooking oil import ban. It could definitely create more demand for domestic bio-based feedstocks. Now, in California's LCFS, there's a fairly large difference in emissions attributed to something like soy biodiesel versus used cooking oil biodiesel. But in something like 45Z and in some of these state level policies, the gap is relatively narrower. So we could see those being an attractive alternative to those if there is a UCO import restriction or ban. Andy, here's a question for you. So what would you say the trade-offs are to different models used for the LCA of fuels? So if a state doesn't have its own agency with the types of resources and expertise, such as CARB in California, what tools are at its disposal to determine which SAF to support? How should it go about that?
Yeah, I mean, that's a tricky question. I think that at the ICCT, we would say that the CORSIA CI values that are also an option for use in the federal credits are, internationally recognized standard that does a better job representing some of the risks of crop-based fuels than what has been done at the federal level. So I would recommend just taking that approach really of adopting what CORSIA has done. It's fairly straightforward. They have default CI values for different pathways, so you don't even necessarily need to do pathway specific life cycle analysis. But yeah, do you have anything to add on that, Jane?
Nothing to add. Yeah, it's very
Okay.
complicated when it comes to LCA models, and a patchwork of models creates a problem with inconsistencies. So the CORSIA is quite a good model to point to, quite a good methodology to point to. It's been created through international consensus and inputs from various LCA teams and trying to reach a representative carbon intensity number while still allowing flexibility for producers to use their own process inputs to really create a more precise number that they can assign to their particular feedstock and fuel pathway.
Yeah, and I guess I would just say without getting into the nitty-gritty details of um, what's happened with the GREET model, I think from our perspective, it is clear that there's been a thumb on the scale a little bit in designed to make crop-based feedstocks perform better than they might in other methodologies, and so we kind of have some caution surrounding that.
I have one last question. This is for you, Andy. I'm not sure if you have an answer to this, but what's a fuel producer supposed to do if their pathway is not listed as one of the options in 40B or 45Z?
That's a good question. I know for like hydrogen, there's a provisional emission rate process that you can go through if you have a novel pathway that's not in the published hydrogen GREET tool. And I would imagine there's something similar on the fuel side, but I haven't looked into that specifically. I don't know if either of you guys know.
Yeah, there's a safe harbor if a pathway is also approved under EPA's RFS or 40B, and then if a pathway exists under CORSIA and has gone through the CORSIA LCA, even if it's not within the GREET 45Z model, can also apply. Now, creating an entirely new pathway, that one I have to double check on.
Yeah, and there certainly will be like long delays if a new pathway is created in terms of getting ASTM certified. So normally these methodologies that are already in place should include all of the commercialized pathways, and they try to get ahead of pathway development. So they're, yeah, easy to point to by using Safe Harbor, by using CORSIA as fallbacks if it doesn't quite exist within the tax credit calculators.
So seeing that we just have a few minutes left, Andy, I just have one last question for you from the chat. Given current market demand for SAFs, does it justify a SAF policy intervention?
I think that policy intervention is needed to get some of these less advanced pathways going because if your facility is going to be running for 30 years to make that investment, you really need some long-term certainty there. And I think that although there is this sort of market demand for SAF right now, it doesn't appear that that is necessarily reliable enough to make some of these investments. So I think that that's really where policies can play a big part, and sort of like what Jane was saying with the contract for difference mechanism, not something we got into, but there are ways of providing revenue certainty for a SAF facility that really help with getting production actually up and running.
Thank you. So thanks everybody for listening. I'll turn it over to Zoe for our final messages.
Yeah, awesome. Thank you, Nick. Thank you, Jane. Thank you, Andy. Really wonderful questions from you all, such thoughtful answers. And we're also aware it's almost the hour, so we are out of time. Thank you so much for participating. If you do have any further questions, you can email them to us, communications@theicct.org, and we'll get back to you. And do remember to follow us at the ICCT on socials. You can subscribe to our newsletters in the chat that we sent earlier. And thanks again. We hope to see you again soon. Bye, everybody.
Thanks, Zoe. Thanks, everybody.